Before you even think about scrolling, stop for 1 second and tap like now, because what you're about to hear is one of those rare discoveries that quietly rewrites what scientists thought they understood. And YouTube only pushes this kind of science when people react instantly. When the James Webb Space Telescope turned its instruments toward Jupiter, the expectation was simple: clearer images, better data, confirmation of existing models. That's not what happened. What Webb saw didn't just look unusual, it looked wrong. Not blurry, not incomplete, but fundamentally incompatible with how Jupiter was supposed to behave. This wasn't the familiar gas giant from textbooks. The cloud patterns were sharper than physics predicted. Heat signatures were stronger than models allowed. Structures appeared where chaos should dominate. For a brief moment, engineers suspected a malfunction. Calibration checks were run, instruments were verified, everything was working exactly as designed, which meant the uncomfortable truth was unavoidable. The telescope wasn't wrong, our understanding was. Instead of a passive planet slowly cooling over billions of years, Jupiter appeared active, restless, and internally driven. Webb revealed concentrated channels of heat rising from deep inside the planet, not leaking randomly, but moving with purpose, shaping the atmosphere from below. This immediately explained why Jupiter radiates more energy than it receives from the Sun, a mystery scientists had struggled with for decades. The energy wasn't excess, it was organized, directed, and that realization alone was enough to unsettle planetary scientists, because once you accept that Jupiter's interior is actively sculpting its atmosphere, every assumption about storms, winds, and climate begins to collapse. And this was just the surface of the problem, because as researchers examined the data more closely, they began to see patterns that didn't belong in any existing theory. Patterns that suggested Jupiter was operating under rules we didn't fully understand yet. If that idea makes you uncomfortable, good, because what Webb revealed next made scientists even less prepared for the reality hiding beneath Jupiter's clouds. What truly alarmed researchers wasn't just the amount of energy inside Jupiter, but how precisely structured that energy appeared to be. Webb detected massive thermal columns rising through the atmosphere, hundreds of kilometers wide, powerful enough to influence storms on a planetary scale. These weren't random updrafts, they were coherent, stable features persisting over time. If Earth had a single structure like this, it would disrupt our entire climate system. Jupiter has many. And if discoveries that challenge everything we thought we knew matter to you, hit like now, because this is exactly the kind of science that rarely makes it into textbooks unchanged. As attention shifted toward Jupiter's poles, the situation became even stranger. Auroras had been observed before, but Webb revealed something entirely different. Enormous electromagnetic vortices spiraling with almost unsettling symmetry, pulsing in perfect rhythm with Jupiter's magnetic field. These weren't chaotic curtains of light, they were organized systems, synchronized across vast distances. For a moment, even experienced scientists struggled to explain how such order could emerge from such violence. And then, Webb focused on the Great Red Spot. Long believed to be slowly fading, the storm wasn't simply shrinking, it was reorganizing itself. Webb revealed layered, shell-like structures inside the storm, behaving almost like a system adapting to changing conditions. Temperature measurements inside the red spot exceeded anything ever recorded, reaching levels that existing models said should be impossible. This meant Jupiter's internal heat wasn't just active, it was interacting directly with atmospheric systems in ways no one had anticipated. The Great Red Spot wasn't dying, it was evolving. And just as scientists tried to process that, Webb uncovered something even more disturbing: glowing filaments stretching across entire bands of Jupiter's atmosphere. They resembled lightning, but they didn't flash and vanish. They remained stable, pulsing with energy, spanning enormous distances. These structures suggested continuous electrical or plasma processes operating across the planet, processes no current model could fully explain. Jupiter was no longer just complex, it was becoming mysterious again. As Webb's observations expanded, Jupiter's night side delivered one of the most unsettling surprises of all. It wasn't dark, it glowed, not from reflected sunlight, but from internal heat radiating upward through the atmosphere. Vast, warm regions drifted beneath the cloud tops like hidden continents of energy, slowly moving and reshaping the visible surface above them. If this revelation feels significant, tap like now, because it fundamentally changes how planets are understood. These internal heat regions explained why Jupiter's storms can suddenly intensify or reorganize without warning. The surface wasn't driving the planet's behavior, the interior was. Webb also detected massive atmospheric waves rippling across cloud layers for thousands of kilometers. These weren't simple wind patterns, they were gravity waves, driven by deep internal activity, transferring energy upward and sculpting the atmosphere from below. Jupiter wasn't just chaotic, it was resonating, almost humming with internal motion. Then came the lightning. Not brief flashes, but enormous electrical discharges originating deep within water ammonia layers far below the visible clouds. These megabolts erupted upward, illuminating entire regions of the atmosphere in a single burst. Their energy dwarfed anything previously observed and confirmed that Jupiter's deep layers are far more active than surface observations ever suggested. Above it all, Webb revealed extensive hydrocarbon haze layers high in the atmosphere, absorbing radiation and trapping heat like a planetary blanket. This insulation effect may explain why Jupiter remains so hot after billions of years. Each new discovery reinforced the same unsettling conclusion. Jupiter is not a simple gas giant. It is a tightly connected system where magnetism, heat, chemistry, and motion constantly interact. And understanding this system matters far beyond our solar system because Jupiter is our closest example of a type of planet that dominates the galaxy. The most unsettling implication of Webb's Jupiter images isn't about Jupiter itself. It's about what this means for everything else. Gas giants are the most common type of planet in the universe, and for decades our understanding of them was based on simplified models and limited data. Webb just demonstrated how incomplete those models were. If Jupiter, studied for centuries, visited by spacecraft, observed by countless missions, can still surprise us this profoundly, then what does that say about planets orbiting distant stars? This is why these images matter, and if you want more science that actually changes how we see the universe, hit like before the video ends. Jupiter now appears less like a static object and more like a living system, constantly moving energy from its core to its clouds, shaping storms, auroras, and atmospheric patterns in ways we are only beginning to grasp. The boundary between a planet's interior and atmosphere is far blurrier than we ever imagined, and that realization directly affects how scientists interpret exoplanet data, model alien worlds, and search for habitable environments beyond Earth. Webb didn't just give us better images, it exposed a gap in our understanding. It showed that even the most familiar worlds can still hide fundamental surprises. Jupiter was supposed to be understood. It wasn't. And if science wasn't ready for Jupiter, then it may not be ready for what Webb is about to reveal across the rest of the galaxy. The universe is not calmer, simpler, or more predictable than we thought. It's stranger, and we're only just beginning to notice.